evening and then weekend. Is that okay? All right. So let's see, air quality data. So what does this mean? So if I want to put a comment, I'll say help on data, right? So how do we get help on this data? Which is to tell us what the data is about. So the question mark is to get what? Help. Okay. So it tells us this is on New York air quality measurement. And it was taken in 1973. I was not born. Okay, so it's a data frame made up of 153 observations on 6 variables. What does this mean? If we say 163 observations on 6 variables and it's a data frame, can you describe what it is? We have 6 columns and what? 153 rows. Is that okay? Yeah. So it has the ozone measured in, I think, ppb, parts per billion. Okay, good. And then the solar, numeric solar lang. I don't know what lang is. Wind should be miles per hour. Then temperature in what? Degrees Fahrenheit. And then the month is just 1, 2, 3 up to 12, just like we know in month. And day 1 to 31. Okay. All right. So here we may be interested in checking whether there is a relationship between wind and temperature. In other words, if temperature increases, does wind speed increases or does it stay the same? Right? Constant and so forth. So what can we do? We can use plot to do this. So that we plot, let's say, wind against what? Temperature. And we'll know whether there is a general increase in them as one increases, the other increase, or something like that. So that's all we want to do. Okay. So what will be our X? Remember, we have a data frame. We want to select a column. What do? We call the name, we put a $sign, and then we select the variable we want. So and as you start typing, as soon as you type A, everything or every object beginning with A will show. So don't don't write all of them. Write about 2, 3, and then you wait, and then you select. Otherwise, when we give you time to do something and you're under pressure, you will make mistakes all the time. So let's say we are taking temperature as X and wind as well, Y. So is that okay? So here too, I'm going to type air. I wait a while. I select quality, air quality. I put my $sign, and then I select what? Wind. Then the type P is point. If you get back to the plot and you scroll down, it will tell you all what the arguments, the meaning of the argument. So type P is for what? Points. L is not 1. L is for lines. Then B is both points and lines. That one, it will just be zigzag. It's always not nice. We can do it so for you to see. So let's plot it. There we go. If you want to color the circles, you can also color it if you want. So we can color like maybe red. Yes. The type. Okay, so P is points. That's why we have points here. If I change it to L, it's going to be lines. It will join the points with lines. No points at all. So you have just lines. And that's all a graph you want to see. Okay. If I put B, it's going to change it, and then the points will also be displayed. You don't want this. You get it? So a graph, you scatter plot, you leave it like that. Okay. You leave it like points. By default, it's points. So you have something like that. Is everybody okay? Then remember that the X label and Y label cannot be having dollar. These days, everybody likes dollar. So if you say you will ask whether there's a dollar over there, right? So you need to change it. How do you change it? S lab is equal to what? Temperature, right? And temperature is in what? Degrees Celsius. So you can even put that there. So in F, to show that it is in what? Fahrenheit. Then once you are done with that, you put a comma after it. What else do you need? Y lab. So you start typing, you wait, you select, you put your double quotation. Y lab is what? Wind speed, isn't it? Yeah. And wind speed is in what? mph. So this, I can just leave it like that. And then I can rerun it. So if I give you an assignment or in an exam, this is what I want to see. So when I'm marking, I'm checking whether if you put a title here, I will take 1 mark from you. Or 2. Why? I talked about it. Why is it that our graph shouldn't have titles over there? Why? We should be able to change. Yes, we'll use figure to name it, right? Yeah, figure something. So we don't need to have this thing over there. Let's get a plot. We are not done. Once we get it, we want to now be able to interpret it. What can we see about the relationship between wind speed and temperature? Now, how do you interpret it? So you will look at it and check if you increase, if you walk along the Y and the S axis, as X is increasing, what really happening to the points? Are they increasing or are they decreasing? So in this case, let's walk from X. The X start from 60 and then it gets to around 100. Around 60, generally the points are what? Are they lower or higher? As we move towards 100, what happens? As we move towards 100, what happens? There is what? Yes, so there is a gradual decrease in what? The value. As X increases, there is a gradual so in other words, if temperature increases, the wind speed what? Becomes slower. Is that okay? This is what we call in correlation analysis. We say we have what? A negative correlation. Go to your graph. Okay, so let's see. So you can take the points. Run that one. The color. So, no, it's not. So that's it. What? It's 4.5. So, why is it not the 100? No, it shows it. So there's a what's the issue with this one? Oh, the issues over there. You see that one, yes. But there's trying to recollect the problem. So it's. Oh, I can't recollect. When I recollect, I'll tell you. But you can switch it off. Exit arrow and open it again. Yes. It's supposed to. Your graph is not taking. It goes to the base and picks it from the base. No, I think your R. When you do it, you throw the R. Last two. Oh, in the house to be one of them. You have to just upgrade the house to be in but it works. Yes, any question? Okay, so is everybody okay with it? So what it means is that when wind speed, if we are interested in, let's say, the wind speed, then it means that on the days that we have high temperature, the wind speed is what? Minimum. Okay, so that's it. Is everybody okay with this? Okay, let's try another one. Actually, you see we have other variables, right? So we can actually get this, all of them. Later on when you do regression as well, you'll be doing this. We can check each of them against each other, right? So wind against solar, against this, and so forth. So that one we can use the function pairs like this. So in that case, we will just pass in air quality. You won't see this until you pop it up out. Yeah. So do it when just pairs. So pairs, as the name goes, pairs. So you take it in pairs. So it will take ozone against solar, ozone against wind, ozone against temperature, ozone against month, ozone against or day. Then it takes solar against wind, and so forth. So on the main diagonal you have them. So if I point over here, that will be ozone and what? Solar. Similarly, it's the same thing over here, but it's turned switch around. Okay, so here ozone is the S axis, solar is the Y axis. When I come here, solar is what? The S axis, ozone is the Y axis. You do this when you are doing regression. You know, in regression analysis, you don't want your independent variables to be correlated. So you can use this to check whether they are related. You get all the scatter plots in there. So please do pairs, and then so pairs is to get it's like a panel plot, right? Or matrix of scatter plot. So that's what the pairs does. So if you are done, then I can zoom it so that we will see what it looks like. Okay. So from this, over here, what is the relationship? Or which variables are we considering with this graph? This one, where the cursor is pointing. Is what? Ozone and wind. Yes. So what is the relationship between ozone and wind? What do you mean by negative? It is negatively correlated. What does that mean? Yes. Okay. So, if on a windy day, what is your expectation of the ozone reading? It will be low. Is that okay? So that's what you use to what? Explain some of this stuff. Okay, what about this one? What a word? You guys see? Oh, this one. Is what? Ozone and temperature. What is the relationship? What does that mean? Okay, so they increase together. When they are decreasing, they decrease together. So if you have a low temperature, you expect the ozone to also be what? Low. Is that okay? Good, okay. What about this one? Mountain what? What is the relationship? Nothing. There's no relationship. They are just scattered within it. Okay, so that doesn't show any. What about this? Day and solar. Also no relationship. This one as well. And so forth. So day and month really doesn't have any relationship with your any of the readings. Okay, it's just something like that. Okay, so that's it. With so please look at. So the data set that was sent, you can check the relationship between what income and let's say the value of the mortgage they gave you. Is that okay? And some of those. Okay, so please take a look at the CARS. So there's a data set called CARS, no CARS 93, CARS. So this one is like when you want to, let's say you work at road safety, what's it? National Road Safety Authority. Yeah. And you need to go to Circle to educate drivers on speeding and stopping distance of cars. What graph will you be using? So you see, in real life, the questions will not come with a graph. Is that okay? So your boss says, we need to go to Circle, mount a projector, project it on the screen, and educate drivers. Christmas is coming, accident too. So it's about speeding and then the stopping distance. So you have the data on the speed of the car and the stopping distance in this and so forth. What graph will you be using to show to the drivers and so what speed you need this? Which one? You have a data set. Speed of cars and the distances taken to stop. Okay, so let's say the police can have this when they have their gun. But sometimes it doesn't work, but they don't force it. Okay, so if you are coming and they point the gun, you should be able to record your speed and the time it takes for you to stop. Is that okay? So we have that data. You want to use it to educate drivers. What kind of graph will you be using? Because you have the distance and the speed. Yes. Can we use box plots? Why? Why can't we use box plots? Because the box plot will only give us how variable the data is. What is the, let's say, the average stopping distance? What is the average speed? What do you think the average speed for? But here we need to study the relationship. That if you are traveling at a higher speed, you need more distance to brake, or you need less distance to brake, and so forth. Okay, so then you will tell them, you can educate them. That when the person goes, they don't go beyond 120. Because if there's a pothole or there's a breakdown track, and you are 120, and it's just after the hill, then you are, there's another track, and then you are, you just go straight and dive or into the bush. So that's the sort of thing we want to do. So if you have that data, that relationship that we are talking about now can help you to educate them. If you go and you write correlation is negative, they won't understand what you are saying. Do you get it? So graphs are very important because it's pictorial and you can design it to make it all more informative and more appealing to your audience. So when you are doing presentations and so forth, graphs are very important, and that's why we are taking our time to go through some of them. So they may be trivial, but it's really important in when you want to communicate the data set. Okay. So let's look at the data. So you can highlight it and display it. So this data was recorded in 1920s. None of us was there. But it has a reference, so we believe. Okay, so here, what will you be interested in? Remember, sometimes you have the variable that is of interest is your dependent variable, but that is affected by another variable. So here, if you are to go to the lorry station to educate them, what variable will you be interested in? And what is affecting it? Distance or speed? Yes. As for the speed, it is in the hands of the driver. Is that okay? They have control over it, but the distance you won't have control because it depends on your speed and also maybe the make of your car, your tires, the weather conditions. A whole lot, even the brand of the car, because let's say if somebody is driving a Rolls Royce, the person can go at a top speed and still be able to brake. If you use other cars, I don't want to mention, you throw yourself into the other one. So the make of the car, all those factors will come in. Is that okay? So let's see. So actually, Distance is what you are interested in. You want to tell the drivers that if there's let's say a vehicle is 10 meters away from you, and you are driving 100 kilometers per hour, you won't make it. You will hit it, or you will swerve and then you meet an oncoming vehicle as well. That's even worse. The one that is going, if you hit it, at least the force will, but the one that is coming towards you, that's head-on collision. So that's severe. Okay, so let's see. We all agree that plot will be good. Now this one, because they are two like this, if I can do this. It takes the first one as a S axis and the second one as a Y. So if I don't do X and Y, it will still work. Is everybody okay with this? Okay. So, but ideally we should, X will be speed and Y will be what? Distance. Okay. So if you are to show this, the drivers will not know what this is. Is that okay? Speed is okay, but we can still, talk about speed in maybe miles per hour or kilograms kilometers per hour or kilograms. Okay. And then the distance in maybe meters. So if you check the data, you know speed is measured in what? Miles per hour. Whereas distance is measured in what? Feet. Okay, so we can add it to this, to the plot. How do we do so? Well, S lab and what? Y lab. Okay, so let's quickly do that. So S lab will be what? Speed. And speed is in what? mph. And then Y lab is distance. And distance is in what? It's in feet. And you run it like this. Now, what we need to do now is to check whether later on we'll be able to check whether this, what we have seen, is even what? Significant and so forth. So we can talk about correlation, but you do all this in your inference class and so forth. So here we are only interested in the graphical output. Any question? Any question? Okay, so let's describe the relationship. What would you tell the drivers from this graph? The higher yes. What will you tell the drivers? Okay. Yes. What will you tell the drivers using this? Let's try. Nobody is wrong here. What will you tell the drivers using this? do you see it here? Yes, you have to point something to show me why you are saying it.
Because when the speed is going high,
Yes.
the distance is stopping distance.
It's longer. How do you demonstrate that here? You draw a straight line. Okay. Yes. So you can take an example. So you say, well, somebody who is driving at a speed of 10 miles per hour will need around less than 40 feet to brake. Now, if you increase it to 25, you need about 3 times that distance. Is that okay? Yeah. So you can use such an example. It will be more appealing to them. So you can imagine if you are driving at, let's say, 60 miles per hour, then the distance will have to be balanced. Otherwise, you hit the next object in front of you. Is everybody okay with this? So that's how you communicate in a layman's terms for them to understand. If you say there's increase, they won't understand what you are talking about. Yeah. Okay. So I think we should be okay with this. Any question? Any question? Okay. So then let's move on. So I think we've done enough on the quantitative data, right? What we are left with is the qualitative one. Okay. Any question? Do you want to take a break? Okay, then let's take. Let's take some 5 minutes break. Step back. Okay, so now when we have a data set that is categorical, so for example, we get data on our religion, sex, our, let's say, ranking on the taste of, let's say, food, or the smell of the food, and so forth. Then we can be, let's say, adding them and so forth, right? Because sex, okay, I'll get maybe the first person is a male, the next person is a female, male, male, female, and so forth. So you get to the last one, maybe female. Is that okay? Now, religion. If we talk about religion, the first person, let's say religion as well, then the first person may be Christian, Muslim, Christian, Muslim, and so forth. So we get to the last one, maybe Muslim, and so forth. So this, if you want to display it, you can be using box plot, histogram, and so forth. Okay. So what graphs can we use? Well, one of them is a pie chart. We can also use what? A bar chart. We can also use dot chart. The dot chart, we can also use it for quantitative data as well, because it just records the frequency as well. So these are the ones we are going to talk about now. Now, how do we do this? Remember that this, if you want to do it, you have to construct a frequency table, right? Okay. So you make, sex, and then frequency. So male, then you count maybe 10, female, maybe 15. So that's our frequency table. If you want to do this, what do? You have to now get a total and calculate the circuits, right? Then you'll be able to get this and say, well, this is maybe female, this is what? Male. Is everybody okay with it? If we want to use a bar chart, then we draw this. Let's say this is 20, so 50 will be somewhere here. So male is 10, and then like that. Okay, so that's the bar chart. The difference between this and a histogram is that this one, they are in groups, no boundary. You cannot be, at least in Ghana, you cannot be within a male and female. There's no boundary. So we leave a space. Is that okay? And only two sex, male, female. Otherwise, they will chase you. Okay. So that's it. Okay. Dot charts are like this. So it's just like this. So male, female. Then we just put a dot like that. That's it. That's the dot chart. Later on, when we do GG plot 2, we can use balloons. If you are dealing with insects, you can get a picture of the insect and use it as a dot. Okay? So if you have a variety of insects, once you give us the frequency, everybody that looks at the chart will know that these they are in the majority. So that's how interactive you can use to do some of these things. If it is Excel, you cannot put a picture there, you know that. So let's quickly do this. And then please tell them that if they are on break, they should not disturb us. Okay, so qualitative data. So what are charts? Let's say charts for qualitative data. So I need to make a comment. One is what? Bar chart, right? How do we construct a bar chart? Well, First, we need to get a table, just like we were doing, and then we will pass the table in a bar plot function. Okay, so bar chart. So A, obtain frequency table. So if we want to do it, we'll first obtain a frequency table, and then next, B, use bar plot function to obtain the bar chart. So basically that's the steps, the 2 steps we will use to get a bar chart. Okay. So let's take an example. You remember our CAS 93? We've looked at the CAS 93 data. Okay. Or let's take another insurance. Let's look at insurance. Yes. Okay. So let's look at the insurance data. That's also in mass. So if you look at it, it says it's a number of car insurance claims. But it's a data frame of insurance consists of number of policies of an insurance and so forth. Made so format, a data frame, district, factor. So a factor is also what? A qualitative data, right? Okay, so there are 4 districts, 4 is major cities. So this, what scale would the district be? What scale of measurement? Look at it. What scale of measurement will be the district? Is it nominal? Look at it all. So it is numbered what? 1 to 4. 4 is major cities. Which means 1 will not be a city, right? Maybe a village. So it will be under what? Ordinal, yeah. There seems to be some order attached to it. Okay, but it still falls under categorical, right? So we can use this to do it. So how do we, first of all, what do we do? Yes. Yes, it's in mass package. Check whether your mass, because it should be there, whether you have take mass. Check the spelling. The I is cap. Still, it's not coming. It is. Okay, good. Okay, so now, how do we construct the table? So let's call that F tab. So we will use table. Okay, so obtain frequency table with, let me add it here so that it becomes easier when you are, and I'll send you this. So we use the code table or the function table to construct the table. So we are going to call insurance, right? So I'll start typing insurance and then I select. What am I interested in? Is the district. So I can then run this. You remember this. What does this mean? If I put all this in parentheses. If I put everything in parentheses, what does it mean? We want to assign and display at the same time. Good. So there we go. So this one, so it's good we are doing this. So the groupings are 16, 16, 16. How do you report this in your, if you have to write a report? Do you need a graph to show this? No. Okay, so if we see a graph, then the person knows you don't know what you are talking about. Because this one, a sentence, you just have to say that there were what? Equal number of what? Policy holders from each district, or selected from each district. That's all. We don't need a graph at all. Is everybody okay with this? So at first I didn't know, but I've gotten the frequency is the same. So I don't even need a table to display this. All I have to say is that there are what? Equal number of policy holders selected from, let's say, each district. 16 or 16 policy holders were what? Selected from each district. That's all. Okay. I can try the other ones to see whether I'll get something interesting. So let me table. If they are all 16, 16, then there's no need. There's also group. So I can insurance, then group. That's also 16, 16. So it's not something we... Okay, age is also in categories. So you see, age by itself is what? Is numeric or quantitative. But we can also collect ages through intervals. Okay, so let me now look for age and see how that one looks like, if it is also different from... Age is also 16, 16, so that's no good. Okay, so we'll get another data set to use. As for these are numeric, so we don't need them. Is everybody okay with this? So it's important that if you have data and they are just the same, don't use table or just describe them. That's also statistics. Okay, so now let's move on. Let's look at the data set cabbages. So we are now in agriculture. So cabbages is also a data frame. It's a data set that has 60 observations on 4 variables. And what are the variables? They are called. That's the cultivar of the cabbage. So 2 levels. So if you go to Agric, they know what cultivar is. I think it's the type. C39 and C52. Okay. So for me to check, this one today are only 2 groups. So I'll talk about cabbages. I'll select cultivar and check. 30 same. It's no good. Okay, so this we can just comment on it. Dates that they were planted. I can also check the days they were planted. That's also 2020. So they are, it's also not a good example. So let's get back to our CAS 93. We've looked at the air quality. Yeah, so let's use CAS 93. So CAS 93 So let's use CAS 93 data. So that one, we can check the airbags, right? Let's look at the airbags. Good. So this one, the frequencies are different. Cars with driver and passenger airbags are how many? 16. Driver only airbags 43 and none 34. So this we can see some differences between it. So this one you can use a graph to to represent it. So I'll call it freq table, which is frequency table. Okay. Now, once you have a table like that, you can sum. If I sum, I'm going to get what? The total frequency. So it means I can also get it in percentages by just dividing each of them by what? The sum. Is everybody okay? And multiplying it by what? 100. And so forth. But let's see how. So now we have our table, frequency table like this. So I can get the bar plot. So to do that, we use bar plot. This bar plot. So what does it say? It says it creates a bar plot with what? Vertical or what? Horizontal bars. Okay. So by default, it takes all the height. There are other arguments you can pass through the bar plot. You can go here and check each of them. Is that okay? Height, width, and so forth. Space, names, legend, and so forth. Okay. So let's see. We will call bar plot. And then the height, it says it needs height. So the height, we select, and then we are going to use what? Freq table. So I do it, and this is it. This is my. Okay, so because I have increased my font size, you can't see the middle one, which is all driver only. The label for the middle one. So what I can do is also to color it. So this one, they are 3, so I can choose color 1 to 3. And then I can reduce the, if I want you to see, I can reduce the size. That okay, it's fine. What sex the label? Let me see. Okay, names. Okay, yes. So you see what I've done. At first you couldn't see so I can reduce the font size. Okay. So the names will be there. That of the axis will be the frequency. And so forth. So now that I've reduced it, you see driver and all, passenger, driver only none. So what can you say about the distribution or the airbag? Or how would you comment on the airbags? Distribution of airbags in the car's data. So here, what we don't want to see is that you start by saying driver and passenger, cars with driver and passengers are around 15. Driver only is about 45. And the rest are that do not have airbag. Okay, you don't need to comment on every one of them. What we want to say, or what we want you to write, is that what are the peculiar nature of this graph. So definitely I can talk about the highest. So I can say the cars that were inspected or whatever it was, most of them have what? Driver only what? Airbag. This one, I'm putting interpretation on the graph that I'm saying. That's what we want you to communicate. Not reproduce what the graph is telling us. Is everybody okay with this? Yeah. And you can say that, well, the cars with dual airbags, that is driver and passenger side, are in what? In the minority. Something like that. And that's it. So as for none, now we know the highest and that one, so definitely that will be in between. You can leave it like that. So what we want is interpretation on the data, not a recollection of what the data or table is actually giving us. Please, are we done? You don't need to put the census name if you can see your own. Otherwise, it will reduce it a bit further. What I'm showing that, well, you have control over what are that. Absolute everywhere. And when we are done with this, we are going to talk about grammar of graphics. So we are now going to break it down into the labels. These are geoms or the geometries. What is actually plotting the graphs. Okay, and then the colors, the aesthetics, and so forth. We will talk about all that later on. So this is base 1. We will expand when we get to the ggplot2 argument. So that's bar plot. Now, remember that once we are talking about tables, then we can also talk about contingency table. What is contingency table? The social sciences, they call it crosstabs. So for example, I want to study the relationship between sex and religion, like we did over there. Okay, so sex, we have male and all, female. Religion, we have Christian, Muslims, other. So in this class, I can ask how many are males and they are Christians? So maybe 15. How many are females and they are Christians? Maybe 10. How many are males and are Muslims? Maybe 8. How many are females and are Muslims? Maybe 12. Okay. Other, maybe 5 and 10. Is that okay? This is what we call a contingency table. We have 2 categorical variables, and we want to cross tab them. So to complete this, I need total here, and then over here to what? Total. So how many are Christians? I add here, it's all 25. Is everybody okay? How many are Muslims? 20. 15. Okay, if I add this, I get a grand total. How many are males? 28. How many are females? 32. So this gives us all 60. When we add this, you also get 60. You add that, you get 60. So this is a complete contingency table. Now we can do so in R as well. So sometimes, if you have this, you can interpret it by also dividing each one by the 60, which means you get 1 here. The rest will also add up to 1. That turns it into a probability. So we can talk about what is the probability of selecting a male who is a Christian. That would be 15 over 60. And you do this in your probability class, isn't it? So now here, we want to see how we can also use graphs to portray the same data that you are using in your probability class. So contingency tables or cross tabulations. So the social sciences will say cross tabs. Cross tabulation stroke or contingency table. Okay. So to do that, it means you have to put the 2 variables in table. Is that okay? So let's look at airbag and what else do we have with CAS 93? Another categorical variable. airbag and type. So we want to check the type of car that has airbag. Okay, so I call it C tab. So that will be table, and then I call airbags. Oh, sorry, cars 93. I want airbags, and then I'm tabulating airbags against what? Against type. So if I do this, I can get this. So there it is. So I need to maybe I should have done it the other way around so we can see it. So I'm doing it the other way around. So now I have, I think, 3 by 6. So but if I do it the other way, you see everything on that. So I want the type to be the rows. So the first one will be occupying the rows, and the second one the columns. So now if I do this, you see it. There it is. So the type, we have what? Compact. We have what again? Large, mid-size, small, sporty, and van. Then you have airbags, driver and passenger. Driver only, none, and so forth. So you see, most small cars do not have airbags. Is that okay? So if you were to interpret this, these are the things you pick up. Okay? And which cars do have driver and passenger airbags? Mostly it's the mid-size cars, isn't it? Yes. And for van and small vehicles, none of them has all. None of them has all driver and all passenger airbag. So you pick these peculiar characteristics of the data out. That's the sort of thing we want you to do. Yes. Okay. The problem is not described as so that's it. Look, so once you run this, shall we pay attention? Once, okay, so if you run this like this, okay, let me clear my, let's say, my console. Okay, so if I run this, please pay attention. If I run this, it will just do my table and save it with the name CTAB. I won't see it on the console. If I want to see it on the console, I can just highlight this and display. Alternatively, you can check your environment. You see CTAB is there. If I double click on this, let's see. It doesn't, for table, it doesn't display it. So what I need to do is just to run this and it displays on the console. Alternatively, you could have just put all this in what? Parentheses. And in that case, as soon as you run, it will do the assignment and display at the same time. So that's how. But you always see the tab in your what? In your values session. Okay. Now, what do we do now? Let's hurry up. Oh, it's time. And tomorrow morning too is another day. Okay, so let's plot it and then we go. So now we can use bar plot. So we are going to do what we call what? Component bar chart. We can stack it or we can do it side by side. So let's see how it will look like. So we pass this one to, so now it is going to plot the columns as one group. So there it is. So you see the first column, you have all the types. The second column, all the types. So, there are 6 divisions, 1, 2, 3, 4, 5, 6. So I can as well do the color. I'll select 6 colors from the rainbow. No, that won't be good. So let me use 1 to 6 because we want to get what do we call it? Legend. So this is it. But we are not done. Nobody will know what you are talking about. What is the blue? Is that okay? What is blue? What is this? Nobody will know what it is. Okay, so you will need a legend. Okay, and the legend should it be legend or legend test? Okay, so let me see. The legend will be the row names. Row names of height. Oh, sorry, no height. Theta. Let me see. Okay. But it is occupying. The legend is even occupying, and it's because of the way I've increased my font size. So you do it, you realize that what is happening is that the legend. Are you bringing me money?
Hey, Professor.
The way you are holding the paper like that.
Okay, you can make a count.
Okay. Okay. Is everybody okay? So do your own, but I can also do the legend outside. Okay, and then that one I can put it here and so forth. You have control, but by default it will put the legend somewhere here. So that's it. So now you will know that, even though we don't know. But you can see it at your end. Because I can't see that side and it's time. So, of course, you know that this is the vans. Okay, so driver and passenger side, we can easily do it. I can rerun this, right? If I reduce my font size, and I rerun it, it won't look like that. Yeah. So this is what I was talking about. Because I have increased my font size, it just override everything. So now I can then increase this. You see now, so that's how R is. Okay, so, but if I pop it out, no, I need to go back. Okay, so now I can pop it out, and then we can see how this looks like. So now we can actually compare them. Is that okay? Yeah. So that's the sort of. So this, it also tells us that driver only has what? The largest share. So we can say that more than there are 93 and 43 in that group. So almost half, right? Yeah. Close to 50% of the cars are only what? Driver side airbag. Now, which ones are in the majority? Which cars? Which type? Is this small? In that case, you have to add all the colors. The mid-side. That's small. But you can check, you can see, you go back to the data. So this is how we will do this. So I think for bar plot we are done. Tomorrow morning I'll talk about pie charts. And then once we are done with that, we will start with what we call data writing. So we'll go back to the data structures, how to add data, how to take out some. And so then we now talk about DPL1, which is the grammar of data writing. So we are gradually getting it. Our target is to get to Spark LYR, which is what we do for the beginning. So this, you have to. So we would be dealing with this Spark LYR. This is what we will be using for the big data. So this helps out to connect to Spark, which is the framework for handling big data. We finish with the data writing, and then we do the plots, and then we now do the Spark. Now the next batch. When you come back again for the second semester, we'll do the second one, then we are now trying to. But that's like you're putting some theoretical courses about it, then we can now start with it. So this here, this one, we are only data, how to display, how to work on the data. So for no model, what we are doing at this display of data, how to work around the data. All right, so let's close now. Please, any questions? The font size is 6. 6 dots. Label. 6 dots. Okay, so have a good night, and God willing, we meet tomorrow at 7:30.